Hey guys, welcome to another video. Today I'm just going to be talking a little bit about a project I've been working on. As you can see from the title, it's about a satellite. So it's a completely unscripted video, just on the workbench. As you can see, it's with some pieces of paper just to cover up the dirty workbench. So I'm just going to get straight to it, and I'm going to be talking about just a little bit about the different parts of the project. So it's Pocket Cube, obviously what I'm working on now, but it's been through several stages. So at the beginning, first things first, here's V1. So obviously you'll be asking yourself, what is this? Why would you need this? So it's a tiny little board, obviously not as tiny, but it's a little board which sends information with a transmitter and with different sensor modules and a CPU. So this has solar panels, and it's supposed to collect information and send it over wirelessly, which is pretty much what a satellite does, but with other parts and little bits and bobs that make it work in space. So this is part one, and the idea was to make the smallest possible information gathering module for the cheapest possible. So here's just with little breakout modules, just simple. Then we passed on to an SMD version. So this is little Sprite V2, Atosat V1, as you can see there, since this was the first actual satellite I was thinking on, not a proto board. And so as you can see, there's little burn marks on here from soldering, but this is an operational module. Has an accelerometer, a barometer, and a magnetic sensor. So it gives all that information, and it has a speech synthesizer to send the information over to software-defined radio, an SDR. So any amateur can literally just tune into this frequency and listen to the information live without having to decode it. So that was also part of the idea. I'll talk a little bit about the RF module on the new version now, but that's pretty much the two basic versions. And so up until this point, I wasn't actually looking at something serious. It was just some sort of information gathering module. As you can see here, it didn't have a specific task to do. And so then I started researching, and I actually found CubeSats, which are the 10 by 10 centimeter satellites launched by universities. So this is just a 3D printed model I made today, just a rough little print. And as you can see, it's 5 by 5 centimeters, so it's absolutely tiny compared to other satellites, looking in the several hundred kilogram ranges. So this is much cheaper to send to space, or to send anywhere, to be honest, even looking at meteorological balloon launches, than a CubeSat. So with CubeSats, you're looking at a launch from 25,000 to 100,000, so nearly the cost of a house. Well, with CubeSats, you're looking at a cost of 8,000 to 25,000, so just about the cost of a car. And this is accessible to everyone. And so the idea now that I actually had something to work on is to make these little sprites. Right now they're 3 by 4 centimeters, but hopefully we'll get them down to 2 by 2 centimeters. To get these little sprites to actually launch from the Pocket Cube. So obviously you'd have to work a mechanical device here to launch them with springs and whatnot. You'd have to CNC mill the whole thing, which will be more videos coming up. But pretty much you'd be able to launch a constellation of micro satellites, pico satellites, directly from a pico satellite itself. So you're reducing the launch cost of a single satellite from the several million to thousands, down to what could be around 20 euros, 10 euros maybe. I mean, in this one here, you're looking at under 10 euros of parts, and you're completely lowering down the cost of single experiments. So each sprite could have several experiments for specific applications. Say one university wants to work on something, or you have a private customer wanting to work on something else. So all this being able to launch from one Pocket Cube. And there's a lot of stuff to take in mind when building a Pocket Cube and sprites this small. It's very hard to work on these things, as they need to be certified for space, they need to work in space. And right now the hardest part is power limitations. Since we're going to these tiny little parts, these little sprites, they're so tiny, there's no real estate to put solar panels on, or to have power for that matter, say battery. Here's some really cheap silicon solar cells which are used on this model. So these just put here, and they fold around this little satellite to give a full view. I'm working with some providers such as Spectral Labs and Trisol X to get some triple junction gallium arsenide cells for this. But the problem is they just don't make enough power for the amount of components on here. And no matter how efficient you make them, you're not able to, let's say, achieve the tasks which you'd like to for that satellite. And up until now, most transmitters used are just standard space-grade transmitters. There's nothing real amateur being put into space, apart from a little satellite I'll talk about at the end, which use some special components. But these are all space-grade transmitters which take a lot of power, and if you want to use with such small solar panels, you need to have them cycled for different times, so have them on for a certain amount of time per minute or whatnot. And so a lot of these sprites, such as ThumbSat, actually I think this is one of the only ones which are this small with solar panels apart from the KickSat project, they actually use a full-size battery, and they don't use solar panels at all. The thing is, I'd like to implement a solar panel in this design as the current launch providers, in this case with Gauss, which is an Italian company launching satellites through the Russian Space Agency, they actually put your satellites into an SSO orbit, so a sun synchronous orbit, and that means it'll be at a pretty high altitude in LEO, LEO I believe, which will be in orbit for up to a couple of years, so I believe most of them last 20 months depending on size, and so that means a battery obviously won't last, since we're looking about 30 days of time with a battery of uptime. And so the idea is to use some solar panels, but that's really hard to do, and then you'd need to look at folding solar panels maybe with such a small size, but then you're already having the sprites come out, so that's all something to look at, and I need to be looking at that with other launch providers, and for maybe different orbits in LEO, so there wouldn't be that problem with solar panels, or looking at maybe solar panel providers for higher efficiency cells. Right now it's right about the 28% mark, but anyways, I digress. That's one of the problems with this. Then you're also looking at all the vacuum and temperature differential problems in space, but right now one of the biggest ones, as I said before, is transmitter. So if we're looking at sending information from space, there's more or less 600 kilometers down to maybe 480, looking at the LEO orbits, to send information, and that's mostly line of sight, though there can also be non-line of sight information sending, though we're mostly looking at line of sight. And up until now, they've been using standard transmitters, space-grade transmitters. But what I'd like to implement in this is actually a LoRa module. So this is an SI4432, which is not a LoRa module, but basically what LoRa is it's a type of modulation or encryption, let's say, to encrypt the information, the packets, into a different sort of information. So you're not just sending it, for example, as Morse code or as RTTY or just simply voice. And so LoRa is able to send information with much less power at much higher ranges. And this other satellite I was talking about, the $50 SAT, did not use a LoRa module. However, the builder, Stuart, I've been in contact with, and we've been talking about using LoRa modules similar to this one to send information. Then also in the solar panel and efficiency and energy and all this side of this project, I'm actually looking at implementing an MPPT board like most satellites. Then you also need to have some sort of backup for SEUs, single event upsets, where you can have bit flips, so with electromagnetic radiation, since these are such tiny satellites without any sort of isolation from the exterior, bit flips often occur in the flash, in the memory and the RAM and everything else. So these bits literally flip, as the name implies, and you have corruption, and so you need to have some sort of backup against this, these single event upsets. You also need to have watchdog timers, as I said before, the MPPT charge controllers for the batteries. Here's in this one we're simply using some step down converters to have a regular voltage from here, and I don't plan on using batteries for the sprites. However, the PocketCube itself will have a battery, since it'll need to be able to turn on immediately after launch, and for redundancy in case we have any issues we'd like to have the battery. We don't want this thing to just be tumbling around through space, receiving intermittent power and being a failed mission. Then you also need to look at passive stabilization in space, so using magnets. There's also active stabilization with electromagnetic coils. But there's so much stuff to take in mind, and really, if any of you are experienced in RF work, in programming in C, and just programming Arduino, as well as PCB design and electromagnetic isolation, as well as all sorts of MPPT charge controller work, feel free to send a comment down below. And if you have any information, as not important as it may seem, it'll really be helpful, and I really appreciate it. So I'll definitely do more updates on this project. So make sure to keep looking at this page, since I'll be posting here often with the next update, hopefully working on V2, so even smaller, and LoRa. And then as far as current launches are going on, I was looking at long-term launches with Gauss for launches with the Russian Space Agency with the Soyuz capsule. It's more or less 25,000 euros, so obviously way out of our reach. However, there are some options for meteorological balloons, and I'm probably looking at doing that probably next month once I get V2 done with a 2x2 centimeter board. And then apart from that, I'm also working on my ham radio operator's license, since we're looking at some bands which are getting out of the ISM as far as power goes. So being able to transmit on 433 megahertz with a 36 watt transmitter really isn't a good idea without a permit. So I'm just working on all of that, as well as permits for the weather balloon launch. And as I said, just make sure to keep updated, and we'll see you in the next video.